This is Dan Abbott. I teach at Southern Maine Community College in South Portland, Maine. This is a photograph of the lighthouse that's attached to our campus from the campus. However, not everyone can come to this campus to take courses, and as a result, we've offered a number of online courses over the years. I've never offered one myself, but we're considering offering one or more of the following classes as a 3 credit college level course. And what I'm doing is providing this video with my contact information so that if anyone anywhere has an interest in doing that, you can contact me and let me know, and then we'll consider putting one up either in the spring of this year or in the fall of next year. The 4 courses that we're looking at are called Parametric Modeling with SolidWorks, which is a first level course, 2D CAD with AutoCAD, which is a first level course, CAD Applications with AutoCAD, which is a second level course, CAD Management with AutoCAD, which is a third level course. These are comprehensive courses. They are challenging and very packed with information. We have a lot of emphasis on what we consider best practices. Our students have done well in applying the skills they learn here to the jobs they get when they leave. For many years, I've been making videos, instructional videos, to assist students in reviewing material presented in class, and many of those are on YouTube in my channel. I'll show you just some slides that indicate the material that would be covered in each class, show you a few examples from each class just to make this a relatively short video. And then if you have an interest, my email address and my phone number are here. Just let me know and we'll take that into account, and I will keep track of who contacts me, and I'll let you know if and when we put these courses up. The SolidWorks class, we call Parametric Modeling with SolidWorks, actually allows students to use other software besides SolidWorks if they wish to, but the course is taught using SolidWorks. It's a 3 credit college level course. It's comprehensive. First course, we don't expect people to come in knowing anything about SolidWorks. There's a heavy emphasis on best practices, which we have gathered over the years by dealing with companies, by dealing with individuals who are working for different companies, by using the software ourselves, by teaching, etc. We have very strong opinions about the way things should be done using CAD software, and I believe good rationale for those opinions. And that means that the work we expect from students has to be done a certain way and has to be done to a certain level. Prerequisites: you have to have an understanding of technical graphic standards. This is based on the ASME Y14.5M standard, and that understanding has to include orthographic projection, and whatever you have for an understanding can be acquired through either education or experience. Topics include solid modeling of parts individually and in assemblies. This is not a surface modeling class. Creation of assemblies and application of limit mates. Production of accurate drawings based on the ASME standards, and the production of a final individual project. I'll show you just one sample project that we do as a class, and I'll show you some of the things that students have done as final project. This is one of the class projects. There are a few videos about this particular project that I have put online. It's called a trolley assembly. This is one of the drawings done that's required, which is an assembly drawing with an exploded view and bill of materials. Individual parts drawings have to be done. They have to meet standards. And if you look at the assembly itself looks like this. Collapse it so that it comes down here. Students have to create this, make all the parts, assemble them together, assemble them in such a way that there are no underdefined parts, and at the end be able to move the trolley back and forth. Check for interferences, make sure there are no interferences anywhere, and then create the drawing files. There are a number of other projects students have to complete as well. This is an example of sort of the mid-range one. Here's an example of one student final project, which is a convertible crib that would convert into a bed for his newborn daughter. This is an exploded view of it. All the components had to be modeled in SolidWorks. If we collapse it, looks like that. Another final project by a student, which is a camp stove. More of a reproduction. It wasn't really as much of a design, but it was kind of a challenge to put together. It included a number of different types of tools in SolidWorks, and again had to be done with a set of drawings, exploded views, etc. It's another final project. I hesitate to show it because it's kind of over the top. I had a student who was really fascinated by clock mechanisms, and so he built the mechanism for a pendulum clock. Looks like that when it's all assembled. That's what it looks like when it's exploded through all the individual parts as well. And if we go back and take a look at the assembly in SolidWorks, looks like this, and he was able to set it up so that we have the pendulum going, and as the clock moved, turn it around here, as the clock moves, you can see that the gearing in the clock is also connected, and he used gear ratios and mates, and I'm running it backwards to make the clock itself work. This is a little extreme. It's a little beyond. In fact, it's more than a little beyond what I necessarily expect from a final project. But you get the idea. The basic thing about final projects is that they have to be something that the person is really interested in doing. Everyone has to take the SolidWorks certification exam, associate level certification exam at the end of the class. You don't have to pass the exam, but you have to take it. A slight majority of my students in the past 10 years have passed the exam. When I say slight majority, I mean something over 50%. CAD graphics with AutoCAD is a first level course using AutoCAD for 2D technical drawing. Again, an emphasis on best practices. We've been teaching AutoCAD here, or teaching CAD classes here, but early since 1988, and we've developed some very strong opinions based on our experience in the field and our experience with companies who use this software, as well as our experience with students. In certain best practices, it should be applied in using any CAD package, and this course emphasizes those best practices and requires that students apply them. Prerequisites are fairly limited. All you need is fundamental math skills that helps to know something about geometry. You have to understand how to deal with Windows-based file management. Although AutoCAD has an Apple version, it is quite different in some ways from the Windows-based version, and what we use and what most industry people use is Windows, and so that's something that you'd have to understand and be able to do. Topics include applying various standards for text, line types, line weights, dimensions, plotting, layer management, producing accurate drawings in a variety of disciplines, although primarily mechanical, and then being able to plot accurately from layouts in paper space. CAD Applications is a second level class that we teach using AutoCAD. Again, it's a 2D class, emphasis on understanding plotting for both metric and imperial drawings, on solving CAD problems that arise in industry, and that means fixing bad drawings. Prerequisites are an understanding of AutoCAD, although someone coming in with a draft site background or other comparable CAD package would be able to do most of the things in this class. Topics include the creation of comprehensive templates, both metric and imperial. We do that in 3 different disciplines, and everyone develops those. The use of scanned images for references in drawing, where you bring them in, scale them, rotate them so that they set up a reference that you can use in creating drawings in AutoCAD. Applying CAD, civil, architectural, mechanical, and structural fields. There are sample drawings that we have people do in each of those fields. You have to create dynamic blocks, create and manage annotative objects, and work with these problem drawings. I'll show you an example of one of them. And use existing Autolist programs, but not create them, but use them as aids in drawing, and also an introduction to the parametric features. This is an example of a civil drawing that required, for one, drawing using surveying units. It also required a use of the user coordinate system to set up a view in terms of drawing the house more efficiently and also representing it. This is a layout with 2 views of the same geometry, and that's required of all the drawings that we do. But this is simply to introduce students to civil activities and also to deal with the problem of having a drawing that was done in feet but is being plotted in inches. An example of the kind of problem drawing that people have to deal with involves a DXF file that they have to open as a DXF file, which I've just done. Then they have to take a look at what the data looks like. This is a real drawing that came from data gathered by GPS information. So all these points, and there are hundreds of them, are located accurately. The software that came with the GPS gathering tool automatically placed text next to the points, and the text, of course, when you look at it, is unreadable because it's so large, but there are 3 pieces of text associated with each point. So students have to bring this drawing in, open it, make a change in the height of the drawing, make a change in layers since everything's on one layer, and then add attributes to the points, create new blocks from each point using a list program that I've written, and then lay this thing out with multiple views at different scales that are correctly labeled as civil scales. And this is the kind of thing that can actually be done in 15 or 20 minutes once you understand how to use something called Q-Select. So that's just an example of the kinds of problem drawings that we use. Another course we're considering doing online is CAD Management with AutoCAD. This is a management level class. It's a third level class. We emphasize best practices there as well, and accuracy, but also speed. We really push people and give them timed drawings, have them answer questions, and efficiency. There's an emphasis on creating programs that are used to automate AutoCAD and on managing file settings and office standards consistently. Students have to create a table of contents for a standards manual. This is a course that requires a thorough understanding of AutoCAD for 2D applications before taking it. You'd have to really know how to use the software. Start off with developing speed, managing the computer system, finding hidden files, for instance, and then being able to use them then when AutoCAD hides them on you. Customizing the interface itself, working with block attributes, tables, XREFs, and fields, creating scripts for managing or automating AutoCAD, creating list programs. There's a significant list programming component to this course. Students are required to develop a number of list programs that can be used in AutoCAD. And then there are some difficult problems to solve with AutoCAD drawings as well, something that I call puzzlers. And at the end, the culmination in this final project is the development of a script batch file and AutoList program that it can be used to update thousands of drawings automatically without any interaction from the user. This class and the CAD Applications class both use CAD secrets every user should know. It looks like this. This is the Amazon site. It was written in 2007, but it was not written as a how to learn AutoCAD book. It was written as a best practices book. Most of it is, well, actually, all of it is still applicable to what we're doing in classes now. However, the software has changed since then, and so annotative objects, for instance, are not covered in the book. Instead, I have separate handouts that I use for those and PowerPoint that I use for dealing with those topics that the students that I give to the students during the class. So that's my question. The format would be Blackboard. People would be submitting work via Blackboard. I would be evaluating it and grading it and returning it to people. So if you have an interest, I'd like to hear about it. Send me an email at diab@smccme.edu. And what we're trying to do is set something up where you can be anywhere without having to come and look at our beautiful lighthouse. We're going to see what kind of response we get, and then I'll let you know if you contact me.